So just recall that if we take the strip parallel to y-axis, then we look at the values of x. The values of x are constant and the limits of y depend on x. If the strip taken is parallel to x-axis, then the limits of y are constant and the limits of x depends on the values of y. Okay, so the next example is evaluate double integral over r y dx dy over the area bounded by y is equal to x square and x plus y is equal to 2. This we have done. Okay. So let's draw the diagram first of all. Y is equal to x square, the parabola opening towards y-axis. Is this example done? Let me just ask you first of all. With limits were given to you. Let's just change this example. Okay. So y is equal to x square, parabola opening towards positive y-axis, x plus y is equal to 2. There's a straight line like this, which will intersect x-axis at 2 comma 0. This will intersect y-axis at 0 comma 2. This is the line. Now we need to evaluate this integral over the region which is bounded by this line and parabola. So the area is this one. This complete area is going to be there. Which strip you would like to take, horizontal or vertical?
Vertical would be better.
Why vertical would be better? This point is 1 comma 1. What about this point? How do you find out this point? You put first equation in the other one. So what we have is x square plus x minus 2 equal to 0. If we solve this equation, then what we are going to get is x equal to
-2.
minus 2 comma 1, right? So if x is equal to minus 2, then y has to be equal to 4. So this point is going to be 4 comma, minus 2 comma 4. This point is minus 2 comma 4. Let's take the vertical strip. So I'll write down, consider the strip parallel to y-axis. Consider the strip parallel to y-axis. So if I consider the strip parallel to y-axis with our remark, if it is parallel to y-axis, limits of x are constant. Where is your x running from? X is running from x is running from
-2 to 1.
-2 to x equal to 1. And y is running from Manas. Wait, let someone else answer this. Y is running from Shivani.
Sir, can I?
Yes, sure.
0 to 4.
No,
If we think about, if we talk about this shaded region, otherwise it's 0 to infinity.
no. Aditya,
Sir, 4 to y, 4 to 2 minus x.
4 to 2 minus x. Sure. This wasn't expected from you, Aditya. Kushi, Oroshri, Saurav, okay, tell me, Manas then. No one else
0 to
will
2
tell.
minus x.
0 to okay, wrong. Look, you need to look at the lower end of the strip and upper end of the strip. What is the lower end of your strip?
0.
Is it
No,
0?
x square.
It is parabola. On the parabola, the value of y is x square. 2. Upper limit of your strip, it is the line. On the line, the value of y is 2 minus x. Hence, put the limits now. Hence, I is equal to integration -2 to 1 x square to 2 minus x y dy dx. Put the values, find out the answer. Do the integration, everyone try this. This kind of MCQs can be asked. Limits are given, find out the integral. Because this is a 2 minutes consuming question. So the final answer is 36 divided by 5. Check it later. Next example.
Sir, can you scroll a bit?
That is integration. You should be able to do it. Next, evaluate. Double integral over r x y dx dy, where r is x square equal to y, comma y square equal to minus x. Let's draw the diagram for this. Y equal to x square is a parabola opening towards positive y. This is actually y equal to x square. Y square equal to minus x. What is it?
Parabola facing leftwards.
Parabola opening towards negative x-axis. The region which is bounded by these two things is this. Now for a change, what I will do is I'll take horizontal strip. Let's fix up the extreme points of this area. This point is going to be 0, 0. This point is this point is
-1, 1.
minus 1, 1. Now the strip is considered strip parallel to x-axis. What is constant when the strip is parallel to x-axis? Let me go back to the remark. If the strip is parallel to x-axis, then limits of y are constant. What are the limits of y? Y is running from, look at the extreme ends and look at the value of y. The idea is when you have horizontal strip, you are going to move that strip upwards down, down to up, or that is how you are going to cover the region. What is the lower end to which you are going to move that strip? What is the lower end?
0,
0.
0,
And what is the upper end?
1.
1.
1. And then you look at the lower left hand side end of the strip. It is on the parabola. What is the equation? So I'll the value of x. The x on the side of the parabola. From this parabola, right? The left hand side end is on this parabola. On this parabola, what is the value of x?
Under root y.
Under root y.
Plus or minus. In the second quadrant,
Plus.
the value of x is negative, so minus root y. Convinced with this?
Yes, sir.
2. Right hand side end of your strip. It is on this parabola. On this parabola, the value of x is
Zero.
nothing but minus y
Minus
square. So x is equal to minus y square. Put down the limits. So I is equal to integration 0 to 1. The value of x is minus root y to minus y square. x, y. What I should write first, dx or dy?
dx.
Dx. Because you can see that this integration is with respect to x. So dx and then dy. Now let's just integrate this. So this is equal to integration 0 to 1. Integration with respect to x. Y will come outside. This will be x square by 2. Limits from minus root y to minus of y square dy. So that is integration 0 to 1 y in bracket. Let's put the upper limit 1 by 2 outside x square. So that will be simply y raised to 4 minus, put the lower limit, minus of root y square. That will be simply y dy. The integration of this, y raised to 6 by 6 minus y raised to 3 by 3, limits from 0 to 1. So the answer is minus 1 by
1 by 12. 12.
So in the next example, we won't solve it completely. Let's just see if you all can try and give the limits for this integration. Evaluate double integral over r 1 upon x raised to 4 plus y square dx dy over the region bounded by y greater than or equal to x square, comma x greater than or equal to 1. Let's draw the diagram. If you consider the equality y equal to x square, so we will have the parabola. And x equal to 1 is a straight line. So since it is an inequality, it represents an area. Like in your 12th standard, you had LPP. The LPP, if it is given that x plus y is less than or equal to 2, what you did was you consider the region. I mean, you put x and y as 0, 0, and you see whether it is satisfying. So the area which includes 0, 0 is your region. So use that idea, and which area here is going to be my region?
Sir, left to the this line and
Left to the line.
for
X
that
greater
y
than
greater
y.
than sorry, right one, right side,
Right.
right side,
X
and
above or below the parabola?
sir,
This
above the
area or
parabola.
this? Above
Above.
the parabola. Okay. So take some point in this area. Okay. So parabola divides this total plane into two parts. Either, let me just take this. Parabola divides your plane in these two areas. So I have to differentiate in which area this inequality is satisfied. So if I take a point on y-axis, say 1, 0. So this area is satisfying my inequality, right? So it is inside the parabola, and x is greater than or equal to 1, so it is ahead of this line x equal to 1. So my area is this. Take the strip which you want, either parallel to x-axis or y-axis. Parallel to x-axis or y-axis, which you want.
Sir, y-axis.
Make it y-axis, okay. When you take the strip parallel to y-axis, consider strip parallel to y-axis, which is constant when you consider the strip parallel to y-axis.
X.
X.
So x is running from. So when you have vertical strip, you are going to move it horizontally. So horizontally, what is your range over which you are going to move this strip?
1.
1.
1, 2.
X
Is there
square.
an end?
So there is no
No.
end basically.
So x is running from x equal to 1 to
Infinity.
x equal to
Infinity.
infinity.
No, sir.
Hello, am I audible?
Yes, sir.
Tell me, what are the limits for y? Aditya,
Sir.
Sir, x square to infinity.
x square to infinity. Exactly. Very good. So y is running from x square to y is equal to infinity. Fine. So I is equal to integration 1 to infinity x square to infinity 1 upon x raised to 4 plus y square dy or dx?
dx.
DX.
Sir, dy.
Dy is very important. You have y as constant here. These are the limits for y. So integration has to be with respect to y first. Fine. So we will look at this now. Area. This is the application of double integration. Application of double integral. So what the definition says is area of a region capital R is given by double integral over R 1 dx dy. So if your integrand is 1, then double integral over the region will represent the area. Okay. But if you look at your 12th standard definition, so if you have a function, say y is equal to f of x, okay, and if I draw the curve like this, y is equal to f of x, okay, and I'm integrating from a to b. Let's take a strip in this. By our double integration study, if I am having a vertical strip, x is running from, this
A
is
to
your
B.
region, a to
B.
b. So we can see that x is running from a to x equal to b. What is the value of y? What is the lower end of your strip?
0.
0, 2,
F of X.
f of x. Okay. So I is equal to a to b. Y is running from 0 to f of x dy dx. Okay, so this will be integration a to b. If you integrate this with respect to y, lower limit is 0, upper limit is f of x. So that is f of x dx. So can I say that whatever we have seen here, that is same as what you have seen in your 12th standard, but the 12th standard knowledge was incomplete. Okay, so simply we were taking it from a to b f of x dx, but the actual definition is this, and your 12th standard formula is derived from this formula actually. Okay, so from today onwards, whenever we need to find the area of a region R, what we will do is we'll integrate from a to we'll integrate using double integral, and whatever the region is, if your integrand is 1, then it will represent the area. Fine. Example, find the area bounded by y is equal to x square and comma x plus y equal to -1. Y equal to x square, x plus y equal to -1. Do they intersect? Let's change this equation. Okay, so x plus y is equal to 2. This point is -4, y will be, sorry, -2, 4. And this point is 1, 1. If I want to find this area, what we will do is area is equal to double integral over the region R. Integrand is 1 dx dy. This is nothing but the area. Give the limits accordingly. If we take the vertical strip, x is running from
-2 to 1.
-2 to 1. Y is running from
0
x
to
square.
x square.
X square to
Sorry,
minus
x
x
square to 2 minus x.
dy dx. So integrating this, we have y x square to 2 minus x dx. This is -2 to 1, 2 minus x square dx. What is the answer? So 2x minus x square by 2 minus x cube by 3 limits from -2 to 1. The answer is give the final answer and we'll stop here then.
Uh, 4.5.
4.5.
5.
Fine. So that's all about the double integral. In the next lecture, what we will do is we'll solve some examples on triple integral where the limits are provided, and in the last lecture we'll do the volume and our syllabus will be over then.
Sir, means based on this topic, you will take only one lecture, then it will be over, right? This chapter.
No, no,